We tend to think of computers as a modern invention. Silicon chips, electricity, code. But what if the roots of computing go back more than 2,000 years? Because in 1901, a group of sponge divers off the coast of Greece recovered a corroded lump of bronze from a shipwreck dated to around 100 BC. At first, it looked like junk until someone noticed. Gears, dozens of them. Interlocking, precisely machined, and arranged in a way no one expected to exist in the ancient world. This was the antikythera mechanism, and it may be the most advanced piece of technology lost to history. At its core, the antikythera mechanism was an analog computer, not digital, not electronic, but computational. Using a complex system of bronze gears, it could predict eclipses, track planetary motion, calculate lunar cycles, and model celestial mechanics with astonishing accuracy. This wasn't guesswork, it was math mechanically encoded. To put that into perspective, nothing approaching this level of mechanical computation appears again for over 1,000 years. Medieval clocks didn't catch up until the 1300s. Precision gear-driven calculators wouldn't emerge until the Renaissance. So how did the ancient Greeks do this? They understood ratios, cycles, harmonic motion, and astronomical modeling. Each geared tooth represented a numerical relationship. Turn the crank, and the future appeared not symbolically, but physically. This wasn't just astronomy. It was information processing. Inputs, transformations, outputs. Sound familiar? Modern computers still do the same thing, just faster, smaller, and powered by electrons instead of bronze. In fact, if you strip away the electricity, computing is really about encoding reality into a system that can be manipulated. The antikythera mechanism encoded the cosmos. And in doing so, it laid down a philosophical foundation for everything that came after. Fast forward to today. Instead of gears, we use transistors. Instead of cranks, we use clock cycles. Instead of planetary motion, we model quantum states, climate systems, and neural networks. But the principle hasn't changed. We're still building machines to understand reality by modeling it. That's why some researchers call the antikythera mechanism the ancestor of modern scientific computing. And while it wasn't a quantum computer, let us be clear there, the mindset behind it wasn't too primitive at all. It was shockingly advanced. The Greeks weren't just observing the universe. They were simulating it, which raises an unsettling question. How much knowledge was lost? If one shipwreck contained something this sophisticated, what else disappeared with collapsed civilizations, burned libraries, and forgotten engineers? The antikythera mechanism reminds us that technological progress isn't a straight line, it's fragile. And every generation rebuilds on whatever fragments survive. Today, as we stand on the edge of quantum computing machines that calculate probabilities instead of certainties, we once again pushing into territory that feels almost mythical. But this isn't humanity's first leap. 2,000 years ago, someone looked at the night sky and said, "We can compute this." And they built a machine to prove it. The future of computing may be quantum, but its roots are ancient. If you enjoyed this video, give us a like, subscribe, and hit the notification bell so you won't miss our upcoming videos. You can also let us know in the comments what topics you would like to hear about. Thanks for watching.